Today I want to show you how to solve some trig equations. So trig equations are unique when you're solving them because instead of having just one answer or two answers, they usually contain an infinite number of answers. Usually that happen at regular intervals. For instance, you might have an answer of 30 and then another answer of 210 and another answer of 390, and it's impossible to list them all. And so what we do in a situation like that is we write down some sort of a formula, perhaps something like this: 30 plus 360k. And k is, it could be n, it happens in different places to be different letters sometimes, but what it stands for is some sort of a whole number. And if I were to put in a 1 into this, 360 times 1 plus 30 gives me 390. If I put in a 2, that'll give me another answer down the line. And sometimes this is 180. In fact, to get these numbers, I think it needs to be 30 plus 180. And anyway, that's the idea. We'll look at a lot of different examples. To solve the most basic types of trig equations, these are the steps. First thing you need to do is to try to get the trig function alone. So sine of x equals number. If you can do that, then you do an inverse trig function to look up one answer. And like in our previous lesson, you'll have to figure out if there's another answer within a revolution that works. And finally, once you have all those answers, you describe them all by saying plus or minus 360k, or in radians 2 pi. So here's an example. We've got the equation 2 sine of x minus 1 equals 0. So the first thing I want to do is to try to get the trig alone. So I'm going to do some moves to get sine of x alone. And so that would look like this. Probably adding 1 to both sides and dividing by 2, and we get sine of x is equal to 1/2. Next thing you need to do is to look up what angles give us sines of 1/2. And so to do that, you're going to use probably a calculator, unless you've got some of these things memorized. I happen to know this one was 30 degrees, but you type second sine of 1/2. It gives you 30 degrees. That's one angle. Then you need to think about whether there's another angle within a revolution that works. And the way I thought about that is to think about the fact that this is a heights problem. Sine is kind of like a height. And there'd be another angle that would be at the same height over here in quadrant 2. And so to find that, we think about this is 30 degrees past 0. I need to know what angle is 30 degrees short of 180. That would be 150. The last thing then, once we have our angles within one revolution, we take those and we say, all right, well, it could be either of those, but I could also add 360 to it and get another answer, like 390 would work, or whatever 360 plus 150 is, 510 maybe. So that's our final answer down here. Well, let's look at another one. So here is 4 cosine of x plus 2 minus 1. First thing I want to do is to get the trig function alone. And so to do that, I'm probably going to subtract 2 from both sides. That gives me 4 cosine is negative 3. And then divide both sides by 4. That gives me the fraction cosine of x is equal to negative 3/4. At this point, I want to look up what angle gives me a negative 3/4 for a cosine. And so I'll be using my calculator for that. When you type that in, second cosine of negative 3/4, the calculator gives us 138 degrees. And so here's a picture of that. Here's our first answer. That's in quadrant 2. And I also need to think about another answer. The second answer is going to be, this is a cosine problem, so I like to think of those as widths. I want to know what other angle has the same width of this one, the same x-coordinate. That would be one down here in quadrant 2. And so to find that, I need to know what the reference angle is to 139. And so I will subtract 180 minus 39. This little bit here is 41. And so the answer I really want down here is going to be 41 more than 180. And so that is 221. So now the final answer then is this combination, 139 and 221, and then plus full rotations more than that. So 139 139, 221, plus 360k. Wanted to take a look at a graph of this a moment. So here is the same sort of problem, and I graphed the left-hand side and the right-hand side and produced a picture like this in Desmos. And the answers, I want you to see here, they're intersections. So right down here, this intersection was the 139 that we got. This intersection over here is 221. And the next answers here and here look like they're kind of the same shape. They're just further on down the line. They're specifically 360 degrees further on down the line. And so that's where this plus 360k comes from. There's more about graphing to solve solutions in the next video, but just wanted you to kind of see that a moment. Here is a little bit more complicated of an equation, but the basic principle is kind of the same. I want to try to get trig alone. And so to do that, I'm going to add a 1 to both sides. That gives me 2 sine of x equals 1. Then I'll divide everything by 2. It gives me sine squared of x equals 1/2. And now to get sine of x alone, I need to take the square root of both sides. But when you take the square root of both sides, you have to think about both a positive and a negative root. And so what happens in this case is that this one equation branches into 2 separate equations, one with a positive square root of 1/2 and one with a negative square root of 1/2. And both of those are going to lead to some answers. If we continue with this one, if I solve this, if I actually type that into my calculator, that's approximately 0.707. And if I go to look up some answers, if I do second sine of the square root of 1/2, I get exactly 45 degrees, which is kind of cool. That, as ugly as that looks, it happens to have a perfect answer. And so that is this angle right here. And I need to think about if there's any other angles that have the same sines or heights, same height. That would be one over here in quadrant 2. And that would be, if this is 45, then this must be 45 short of a full 180. And so that would be 135. So here are 2 of our possible answers. But we also have answers that come from solving this branch. And so if I typed second sine of negative square root of 1 over 2, I get, I didn't type this one ahead of time on a picture there, but when I typed that, the calculator gave me negative 45. And so that is this answer over here. And sometimes it's okay to write your answer as negative 45. Other times teachers want answers specifically between 0 and 360. And so this negative 45 is the same thing as 315 degrees, if you had to write it that way. And the other answer, in this quadrant, there'd be another angle that's the same height, and that would be 45 degrees past 180, which is 225. So we have 4 different answers within one revolution that we need to all write as our final answer. So final answer here would be that x could be 45 or 135 or 225 or 315, or you could take any of those and add multiples of 360 to it, and you would get other additional answers. So that's kind of neat. Lots of answers there. I will suggest there is a shorter way of writing this. In this case, the answer's 45, and then exactly 90 degrees later is 135, and then exactly 90 degrees later again is 225. This long expression could be written a little bit more succinctly, like this: 45, actually there shouldn't be a k there, but 45 plus 90k. Anyway, you don't necessarily have to do that, but you might see that sort of thing in an answer key somewhere. So let me clean this up a bit because that's driving me crazy. There we go. All right, one last example for you. This is a cosecant problem. Okay. Well, the first step is going to be the same. I want to get the trig alone. So I don't like that 5 in front of it. Let me divide both sides by 5. And that gives me cosecant of 2. And normally, once I have trig alone, I would reach for my calculator and try to type something in. But there's no cosecant button on the calculator. And so we need to do one more thing first, and that is kind of a weird move. We're going to take the reciprocal of both sides. So on the left-hand side, the reciprocal of cosecant, 1 over cosecant. And on the right-hand side, the reciprocal of 2 is just 1 over 2, 1/2. And 1 over cosecant, the reason I took the reciprocal is that is sine. And now I've turned this problem into a sine problem, which is a good thing because I can type that into my calculator now. So I need to look up what angles give me sines of 1/2. So it's possible, actually. Some people have this memorized. This happens to be one of the nice angles. So second sine of 1/2 is exactly 30 degrees. So that's this angle here in quadrant 1. And another one that is the same height would be over here in quadrant 2, and that would be 150. So final answer here is those two plus 360k. So there's a basic idea on how you can solve some trig equations. They can and will get more complicated than that, but maybe not in Algebra 2. I know my pre-calc students, we get some harder ones. But anyway, that's the idea. Let me know if you have any questions, and I'll see you in the next video.